So greetings, everybody. Robin, can you see my screen okay?
Yes, we can see you. We don't necessarily see your screen.
Really? Okay, give me a second.
Yep.
I have to reshare it.
Okay. Looks like, yep, we see it just fine.
Terrific.
Slideshow mode.
Yeah. Okay. So welcome, everybody. I'm Glenn Schwartzberg from interRel Consulting, and today we're going to be talking about hybrid Essbase 101. So some things about what it is, some tips, tricks, and some of the best practices for it. A little bit about me. I've been doing Essbase since about 1992. Doesn't mean I'm any good at it. It just means I'm old. I'm an Oracle ACE director, which means that I get to go out and evangelize the products. And in my case, I've been lucky enough to work with the development team quite a bit on the cloud versions of Essbase. First, Essbase on OAC, and then in 19C. And I've gotten to see a little bit about what's happening with it in 21C on-prem. This presentation is not going to be strictly Essbase, although it is talking about hybrid, because hybrid is applicable to multiple products. So we kind of get a little flavor from all of them. I'm not going to go into a big advertisement for interRel Consulting because you're on the conference hosted by them. I'd just like to thank Edward for taking the expense and the time and resources for putting the conference together. So if you want to read more about us, go to our webpage, or there'll be these intro slides in what you get. So first of all, let's talk about what hybrid is. And I love the pictures that I had chosen for this thing. So the first thing we're going to talk about is block storage option, or BSO. Block storage option is the original Essbase type of database that I had when I started. And it's come a long way since the version 3.1.1 that I started on. It's a very powerful calculation engine. It pre-stores all of the information, but because of the way that it pre-aggregates data, we're limited to the number of dimensions that we can have in a BSO database. Because we could have billions or trillions of intersections, it can be very slow to aggregate, to do calculations on. But it does give us that ability to run calculations that are procedural in nature. So I do one calculation, based on the results of that, I do another calculation based on the results, etc., etc. It uses a proprietary calculation language that we just call the CalcScript language. We're so original here. Data can be written to any level within the database, but we actually discourage that. We prefer to write it at the bottom level because we've run into problems with data getting overwritten and other things. It's very, very structured. And you have to understand the concept of dense and sparse dimensions. And I'm not going to go into that here today because I could have a whole session just on dense and sparse. So then we get into ASO, and ASO is a lot more freewheeling here, as you can see by my picture. We can have much, much larger dimensions. One of my clients has a dimension that has 23 million members in it. We can have a lot more dimensions, and there's no reason for us to aggregate up the database. So it means that we can load the data in, do a retrieval right away at the upper level, and get a result. You know, with the BSO cube, we could have taken hours in order to do that aggregation. So this really solved a lot of needs. There's a lot fewer calculation options available. In a BSO cube, we had formulas, unary operators, and we also had that procedural calc script. In an ASO cube or aggregate storage cube, we only have the ability to do unary operators, consolidation operators, which roll up. And in some cases, we can only do additions. For example, if we have a stored dimension, then all we can do in that dimension is add up all of the children in that dimension. We can't do minuses or divides or percentages, anything else. Instead of that proprietary CalcScript language, it uses the more open multidimensional expression language, or MDX, that was based on a consortium of a number of companies. It's interesting that they've kind of gone their own ways about that now. There's a lot of differences in the different flavors of MDX now. Data can only be stored at level 0 members. So we can't store data at upper level members because we're always going to be aggregating up those bottom level members and getting results from them. And we don't need to worry about no dense sparse configuration. That really doesn't play into how an ASO cube works. Technically, there's one dense dimension in it, and it's whatever we set our compression dimension to be, because that actually stores all of the data in one place. So what happens if BSO and ASO had a baby? So what we're going to get is hybrid, and hybrid really is the love child of BSO and ASO. So like his mother, we get extensive calculation capabilities. We have the CalcScript language available. It does use dense and sparse dimensions, but they're not quite as important as they are in a BSO cube. It will actually be a little bit different on how we do our configuration. Like his dad, the ASO cube, we get more and larger dimensions, and we can only store data at level 0 members. So we kind of get the best of both worlds. Now, he does have a recessive gene that can show up, and that's that you can mix and match whether or not you want a cube to be fully hybrid or if you want it to be partially hybrid. And we'll actually talk about the reason and the use case of why you might want it to be partially hybrid. In many cases, it will actually improve performance for us. So the 3 types of cubes, just another way of looking at it. You know, we have the block storage, powerful calculation engine, limited in size, ASO, blah, 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 blah. And basically, I said all of this to you a few minutes ago. So I'm going to move on. So some of the issues that we run into with a BSO cube are sparse dimensions, especially large ones. We can't dynamically calculate them because it has to bring the blocks into memory to do that. And if we have 1 million members, we really don't have the memory to bring in 1 million blocks. Stored sparse dimensions increase our aggregation time and the database size. The issue with ASO, it was really meant to be for what I call rack and stack operations, where you're going to just be adding up these really large dimensions. And we don't get that powerful calculation engine that we have in BSO. So hybrid is the BSO functionality, ASO performance, and the BSO calculation engine. So how does hybrid really work? Well, there's 2 calculator engines in the cube. And We don't say that there's three kinds of cubes, by the way. There really are only two types of cubes. There's BSO and there's ASO. And BSO can be hybrid enabled, or it might not be. And if it's hybrid enabled, then it's going to take advantage of that second calculation engine in the ASO query processor. So based on how you have it set up, if it thinks it can use the ASO optimizer, it will. If it can't use it, it will turn it back into a BSO mode cube. And depending on how we have things set, it can actually impact our performance tremendously. So how do we make a cube hybrid? Well, in a minute, we'll go over another slide because it's going to depend on the version of Essbase that you have. But basically what we're going to do is we're going to take all of our sparse dimensions and we're going to make the upper levels of the dimensions all dynamic calc. Now, typically we're already making our dense upper level dimension members dynamic because for years that's been an optimization technique to reduce the block size. Because a dense dimension, everything is in one block. So if I made all of the upper members dynamic, it's only looking at one block to do that calculation. In a sparse dimension, in a regular BSO cube, if I did that, it's going to be a huge retrieval hit because it's going to have to do that calculation every time. In a hybrid cube, it just uses the ASO query processor and makes life a lot easier. Now, Oracle does have a design guide to help with the design and tuning recommendations, and I actually have taken some of my recommendations in here from that guide. It was written by Mike Larimore in 2008, and I'm going to stop sharing for a second. And this is the guide that I used, and there's a link in it in the presentation. And so I'm going to go back to the presentation now. The other thing that a lot of this presentation was based on is when hybrid first came out in planning, we were lucky enough to be on the beta of that, and we did a lot of testing of using hybrid in EPM Cloud. And so some of the recommendations in here are based on that testing that we did there. So this is my little bubble chart of some of the benefits. We're going to reduce the database size, the footprint on disk, because we're not storing all of that upper level data anymore. I've been able to take a database that was 30 gig and bring it down to 500 meg on by turning it into hybrid. It improves the refresh performance. Again, all related to the amount of data in it, because I don't have to restructure billions of blocks. I'm just restructuring the level 0 blocks. Reduces the time for data export and import, especially if you're doing level 0. It can actually increase the time if you're trying to export upper level blocks because you actually have to calculate them. But if I'm doing a level 0 export, it's much quicker. Because of all of this speed, I'm going to reduce my maintenance window because I don't have to do the aggregations. The aggregations typically are what take the longest amount of time in any of my processing window. We're improving the performance of most business rules because, again, I'm only dealing with looking at the indexes on my level 0 blocks. And it's going to improve usability because I can add more into the cube in order to make it more functional. Now, not all versions of hybrid Essbase are the same. It came out in 11.123 500, I believe, and it was extremely limited. 501 and 502 made it better. 11124 made it even better. In Planning Cloud, when they first initiated it, it was a special version of 11124 that was more functional than the on-prem 11124 version. In Essbase 11.2, it is pretty much the same version that it's using in Planning Cloud, which is an 11124 version. But like I say, it's a special version. Unless, well, I won't even go there. And then we have it in OAC and Essbase 19C. In OAC, and I'm skipping EPBCS because that really is Planning Cloud. In OAC, it uses a better version, a fully functional version that's higher than what's in Planning Cloud or on-prem. It uses what's called 12C. In Essbase 19C, it has an even more advanced hybrid engine where they've added feature and functionality to make it work on more complex calculations. So depending on where you are, there are different things that you have to do to enable it and different feature functionality that you're going to be able to get out of it. So how do we take advantage of hybrid? Well, if you're on-prem, you actually have to turn on hybrid in the Essbase config file, and know that it's not officially supported for on-prem planning. There's a lot of people who have done it, including interRel for clients, but it's not officially supported. In OAC and Essbase 19C, it's enabled by default. There's no further action needed for you to do it. However, you will want to turn on the configuration setting hybrid BSO in CalcScript in order to get the full functionality running in your calc scripts. Conversely, we found out that once in a while we want to turn, and I spelled CalcScript wrong. I just added this into my slides. This should be in CALC. I just noticed my spelling error. In rare cases, we needed to turn that off, but 99% of the time, you're going to want to turn it on. So if you're in the old PBCS before they went to the new arrangements, there were required steps that you have to do in order to upgrade it and convert to an ePBCS application, and you actually had to get Oracle to turn it on for you. In Planning Cloud, the new EPM cloud, it's on by default, and in financial close and consolidation, it's on by default as well. So as I said before, in all of these, in order to get it to actually work, once you've turned it on, you need to set the upper levels in the sparse dimensions to be dynamic calc. Sounds counterintuitive, but that's actually the way it looks at things. So in on-prem and in EPM cloud, EPBCS, etc., there are some calculation functions that are not supported in hybrid mode. And if you look at the documentation, there's actually a list of them. And I'm not going to go through all of them because every version is different. So look at your documentation to see what's not supported on the versions that you're on. Be aware that if you're on 19C or OAC, everything is supported. And if you're on 19C, it will even work better than if you're on OAC. The way you can tell if it's turned off, if you look in the log after you've run a calculation or done something else, you'll see a notice that says hybrid aggregation mode disabled for whatever, for a member due to, and most likely it's going to be complex formula or a backward, what do they call it? A backward reference. So what my recommendation is to see if it works is to turn it on to test the calc script or rule that you're going to run and test it under various conditions. So test it, look at the log, test it, look at the log, test it, because different things will turn it on or off. And sometimes you have to do workarounds in the older products in order to get full functionality, especially for some of these functions that don't work. So how are some of the things that we can do to make hybrid more efficient? Well, first of all, what dimensions do we want to make as sparse or dense? And so this really hasn't changed much, although we can make fewer dimensions dense to make it act more like an ASO cube. In some cases, I'll just make my accounts dimension a dense dimension and even leave periods sparse. But most commonly, accounts and periods are dense. Sometimes we're going to want to make more dimensions dense, especially if they're not volatile. So if we have a dimension like a view dimension or something else that doesn't ever really change, it may be worthwhile to make it dense. Obviously, because of attributes, anything that has an attribute dimension associated to it has to be a sparse dimension. If we have really, really big, deep dimensions, customers, products, stores, those type of dimensions, you're going to want to make them sparse. And remember, even though they're really big, we can turn on and set the upper levels to be dynamically calculated now. So what our goal is actually to have an optimal block size. So we don't want it really big, and we don't want it to be too small. I mean, I've seen it where I had a block that basically was 8 bytes, which was because they had a single member in the block. So we want to make it so the block gets filled as possible. Accounts dimension is a really good one because it has a lot of formulaic members in it, and that works really well with the turning on the aggregate engine. So if you're doing it in planning, it's going to not let you make the block too big. But if you're in pure Essbase, it won't stop you. Like I say, while it's typically accounts and periods, you're going to want to play with different dimensions in your hybrid cube to see what the impact is on having different dimensions dense. We also have to balance what we set to dynamic calc. So if it's dense dimension, we're never going to have a problem with setting those to dynamic calc. With sparse dimensions, you can set as many as you can, all of your dimensions, to see what you can do without impacting both calculation and retrieval performance. Obviously, a leaf member can't be set to dynamic calc if there's no formula on it. If there's a formula on it, then of course you can set it to dynamic calculation. One of the things that we have found is that it's not necessarily best practice to make all of my sparse dimensions upper members dynamically calculated. In some situations, we get much better performance if we take and we store at least part of a dimension or one of our heavily used queried dimensions, if we just leave it as stored. And I had a calculation in a pure BSO cube that ran for 3 hours. And we tried to make, and we said, okay, we're going to make this a hybrid cube. And I turned on all of the dimensions to be hybrid, meaning I took all of the upper level members and I made them dynamic calculation. So I had no calculation time. It went from a few hours down to nothing. But when I was doing calculations, procedural calculations against it, or when I was doing retrievals, my retrieval time, and I'm going to use a technical term here, sucked. So I went back to the cube and I took my largest sparse dimension, which had about 300,000 members in it. And I turned the upper levels back to sparse. And I have to say that a lot of my calculations also dealt with this one dimension, because I was doing things like percentages of the total and all sorts of things like that. So I went ahead and I made that one dimension, like I say, hundreds, thousands members, and I made it stored again, and I just ran an ag on that one dimension. That one ag took about 23 seconds because it wasn't aggregating all of the dimensions. It was just aggregating the upper levels of that one dimension. And by doing that, my retrieval performance went down from, and I'm guessing at the numbers, from over half a minute to like a half a second. And those are not my real exact numbers, but that's an estimation because I don't remember what the real numbers are. So if you take nothing else away from this presentation, this is the biggest one that I want you to take away, is that you may want to store one of your dimensions and use it, just calculate it. So we also have to understand the calculation order of calculation hybrids. Hybrid was really designed to follow the calculation order of the classic BSO cubes. And obviously dynamic calculation changes the order in which Essbase is going to calculate values. So by changing the dynamic settings, the dense sparse, and we can lead to some incorrect results. Now, what's really nice about hybrid, dramatic pause for a drink, is that they've given us the ability to not only use to-pass, but also to use solve order. So there's two ways that we can deal with both calculation speed and calculation results. The first one, and sometimes it will have significant impact, is to change the order of the dimensions. So by default, some of the data is being calculated later on. The other way we can do it is by using solve order to influence or to force the order in which things are getting calculated. So if we're looking at the calculation order of cubes, and I need to speed up a little bit. This is the order of the way block storage cubes do calculations, and the way that we do it with dynamic calculation. So basically what we want to do is we want to order our dense dimensions first, then our sparse dimensions. And if you've got sparse dimensions that are doing heavy calculations, put them later on to make sure that the other sparse dimensions are getting aggregated first. That's the second takeaway that we found in our testing, is that by either increasing the solve order or moving those heavy calculation dimensions later on, the sparse ones, we're getting faster performance, we're getting accurate calculations. And Mike Larimore in his document has a really good example of how he did that. And yesterday, Mike showed us in the new Cube Designer coming out, there will actually be an optimization utility built into it where it will help you determine these kind of things. So coming in the future, I can't say how soon or how far away, using the Cube Designer against Essbase 19C, or when 21C comes out on-prem, you'll be able to use it to help you define the sparse order of your dimensions. Now, there is a default solve order in 19C that it follows. So stored members are set with 0, sparse dimensions get 10, and I'm not going to read you all the numbers, but you can see what the order is. And this is what the default is that it's going to use in 19C. It doesn't mean that you can't change it on your own, or for either a dimension or for as an individual member. You can definitely influence it. Now, one of the things that you can do in 19C that you can't do other places, actually you can do it in 12C as well, I believe. You can turn on a setting for the application called Hybrid Optimized Solve Order, and that's going to have it set these default values. And again, by default, it's actually turned on. In some cases, I've turned it off because it was resetting things and actually not giving me the order that I really needed the calculations to work in. So what you're going to want to do is you're going to want to set your solve orders. First, I let Essbase run in its default order, and I see if I have incorrect results, or I see what the performance is. And then I'll go ahead and I will try doing things like changing the solve order of members. And remember, when you have solve orders, that the higher the number, the later in the calculation it will happen. So it's first going to do anything with the 0. It's then going to do anything with the 5 or 10 or whatever number you set it to. Then it's going to do a 20, then a 50. Finally, it's going to, in this case, it's going to do the 90s last. And you can go up to 127 in solve order as an FYI. So test that out, test the solve order. If you've got multiple solve orders in a single dimension, it's going to work top down if they have the same solve order. So if you have everything with a solve order of 0, it's going to work from the top and work its way down through that list. Then it's going to do the 10s, then the 20s, etc. In a single dimension, it also does it across the multiple dimensions. And the reason why this slide is because it's going to do it in this order as well, based on if I have equivalent solve orders across multiple dimensions. It's also important to understand how asymmetrical queries and reports work, because the hybrid engine is very, very efficient in doing symmetrical queries. It can submit the query as a single grid back to the query processor and get one result back. If I've got asymmetrical reports where I've got a lot of variance in them, it's going to go ahead and create multiple little tiny grids in order to send the information back. So one of the things that you can actually do in order to influence this is, obviously, if you can design the cube so when people are retrieving it, they're going to bring back larger grids of data at a time, that will improve your performance. The other thing that you might need to do or might want to do is sometimes you're going to set a member to be stored and pre-calculate it in a calc script. And I know that goes against the idea of hybrid that says, well, it's more like ASO, but sometimes what we want to do is we want to store the result and then let it roll up. So for example, if I had a member called sales that was units times price, I don't want to set that to be dynamic calc. What I want to do is I want to calculate it at level 0, because that's going to be really fast, and then let the aggregation engine roll it up to the different members in the different dimensions. So that's just another way of doing it. So one of the ways that you can actually do this is in 19C, there's a new term called an odometer, which represents the number of queries that the query engine had to execute to complete the query. And a single query is going to have a value of 1. And an odometer value of 500 means that it had 500 little grids that it had to bring back in order to do that. One of the ways that you can do this is if you set the configuration file of long query time threshold to be like 0.01, what you'll get in your log file is you'll get the output of that odometer, and you can look at that to see how it is performing, and then you can tune based on that to see how efficient your queries are doing. So get a bunch of queries from your users and try out different queries and see how the performance is going. Other consideration, attribute dimensions, they're always going to be calculated last. So, which means that it may not always be giving you the correct results. In some cases, because it's more of an ASO type of behavior, you can turn your attribute dimensions into real dimensions, and you're going to get better performance. Now, one of the things that we have in ASO cubes that I probably should have mentioned is ASO cubes, you could run aggregation, you could run query aggregations, which set intermediate levels to improve query performance. As of today, we don't get that option in hybrid cubes. I know that Oracle is working on it, and they're actually going to make it so you actually don't have to set anything, that it's going to be dynamic. If or when that ever comes into play, I don't know, but I do know that they're working on it. So what are some of the best practices when we're creating formulas? So any formula that can be calculated after an aggregation, such as a ratio, should have a higher solve order because you want it to happen later. Obviously, any formula that's got to be computed before an aggregation, if performance is okay, great. If not, make it stored and put it into a calc script. Running a 15-second calc script is not a big deal. So, and then any formula that's going to be grabbing a really large number of blocks, such as a rolling forecast or an allocation process, again, because we're going to do it on level 0 blocks, consider making it a stored member. Other BSO tips that still apply: we want to reduce fragmentation, we want to remove empty blocks. You can use calc parallel and fix parallel. In Essbase, we can change the cache settings. We can't change them in Planning Cloud. If you can get away with not using XREFs, more power, that type of thing. So I'm going to skip this whole section. It was just some of the things that we found out when we were doing planning because I'm running out of time. So basically, hybrid BSO is better than BSO 99.9% of the times, because even if I make a BSO cube hybrid and I don't use it, I still gain some of the features of hybrid. Hybrid BSO doesn't replace ASO. There's still a place for ASO, and it's still going to make sense for some cubes. But if I'm using features like sandboxing or other things that only work with BSO cubes, hybrid is definitely the way to go, and you need hybrid for sandboxing. I had a client that wanted to use sandboxing and had an 8 million member dimension. We turned the cube into hybrid and it worked great. We made one dimension stored, so that my mixed approach is making some dynamic and others stored. That worked out great for them. They were able to do what if scenarios that they were never able to do in their ASO cube. Migrating from BSO to hybrid works, but it's not going to just be turn it on and expect it to work. You really do need to test it. So I put some links in here. The bottom one is the link that I got a lot of this information from Mike Larimore. Thank you, Mike, from Oracle. And if you have any questions, please put them either into the chat window or into the Q&A window, and I'll be happy to answer them. If you don't have any questions, I've got 1 minute left, so I'd like to thank you for joining me today, and I hope you enjoy the rest of the conference. And
Hey, anybody have any questions for Glenn?
I either did a really good job or a really bad job and put everyone to sleep.
No, I think you did a great job. You had record attendance at your session, so very, very informative.
Oh, and if you want a good session tomorrow, Edward and I are going to discuss the advantages of Essbase 19C versus freeform planning. That should be an amusing, interesting presentation.
Amusing, to say the least. All right. So looks like we have one chat. Just thanking you for a great presentation presentation, Glenn. So thank you once again for imparting your wisdom on the rest of the community.